All right, I got a video over the Unit 6 multiple choice quiz. So the first one says which one's not a random variable. And I'm not going to read them all out, but I'm going to tell you the reason why it's not D is because it's based on your favorite. You're not just reporting facts, you're reporting an opinion. So D is not a random variable. All right, this one, this actually says, something's brought to my attention today. It says this is the number of heads and says what's probably getting at least one tail. Now, because these probabilities mirror each other, like 0 and 4 is the same, it really doesn't matter, but really probability at least one is usually 1 minus the probability of none. And we still will do that this time, but it's not none here, it's actually none here. At least one tail means not 4 heads, so it's actually these. So you can either add these up together or do 1 minus 0.0625. I always just gone 1 minus that. Never noticed before that I was reading it wrong, but I'm still getting the right answer somehow, luckily enough. So that one's D. All right, number 3. Number 3, you pretty much need to make a probability model like this. So we can win 0, 1, or 4. We have you know what? I'm gonna 3/6, 2/6, and 1/6. And then we plug those into a calculator and already have those done. Let me zoom in a little bit here. All right, so 0, 1, and 2, 1/2, 1/3, 1/6, and then stat calc, 1 var stats, and remember this frequency list. This will be cleared when this will look like this, where it's empty when you take your test. You hit second 2 to get L2 and then hit enter a couple times. And the mean is 1 and the standard deviation is 1.41. So 1.41C. All right, next one, they give us a probability model and they ask for the mean. So on this one, I'm gonna go stat edit, 0, 1, and 2. I'm just gonna override the numbers that we had from the last problem. And then stat calc, 1 var stats, and again, frequency list is already in there at L2 because I've already done that. The mean is 1. You can also get that one by just multiplying. So 0 times 0.2, 1 times 0.6 is 0.6, 2 times 0.2 is 0.4. Add those together, 1.0. All right, the next one, for the density curve, these are the two that we've seen before. That the density curve, the total area under the curve must be exactly 1, and the area of the curve lies, the whole area of the curve must be above the horizontal axis. We've also done this one now in Unit 5, that the probability that x in a continuous random variable is equal to a particular value is approximately 0. It's actually 1 over infinity, but that's approximately 0. So that one's right, and if these 3 are right, then they all have to be right. That one's all of the above. The next one says we have a mean and a standard deviation, and then they want to know 60% is below what? That's inverse norm. Haven't had a lot of inverse norm for a while, but that one's going to be areas 0.6. Also, I don't have to do the hundreds partner because it said less than, which is nice. I would rather not have to mess with any weird stuff like doing hundreds partners. So second distribution, number 3, areas 0.6, 360, and 50. And then most of your calculus will not have this left, center, right business. So 372, 66, or 67, I guess. And then this one is much closer to choice D than it is to anything else. It's not exactly D, but that's the right answer. All right, grapefruit has a mean of 1 pound with a standard deviation of 0.12 pounds. What about 3 randomly selected? So I have mu of x of 1 is, mu of 1x is 1 and sigma of x is 0.12. So now I'm gonna say mu of 3x, or you could call it a different variable or whatever, but I'm just gonna go with this. And that's just 3 times 1, and that's 3. Piece of cake. Sigma 3x is 0.12 squared plus 0.12 squared plus 0.12 squared, or 0.12 squared times 3 because there's 3 of those. That's the hardest part about this question, without a doubt, is getting the new sigma. and I'm going to call that 0.0278 is the mu of 3, or sigma 3x. I just said mu, I'm sorry, sigma 3x. So anyway, now I do normal CDF. And it wants to know that they weigh more than 3.4 pounds. So lower is 3.4. Upper, like 100, that's ridiculously large. Mu is 3, and sigma is 0.2078. So normal CDF, and then 3.4 to 100, 3, and 0.0278. And I got 0.027, which, choice B. All right, so there's the hard part of this question. Sneaky. That when you look at that question, it doesn't look like it's going to be that difficult, but that one's kind of sneaky. All right, this one. On this problem, we say we have this person, I think it's Sule, if you pronounce that. If it's not, I don't, that's fine. So it says bus, the mean is 12 and the standard deviation is 4. If I walk, the mean is 16 and the standard deviation is 1. What's the probability one to be faster than the other? That's one of those, it's like the speed dating question. So over here, now this one's not a full write-up. I don't have to write all the steps, but I am going to write that I'm going to do the difference is going to be, so it takes longer to walk than it does to do the bus. So I'm going to do difference is walk minus bus. So the mu of the difference is the walking time 16 minus the bus time, or bus average. Walking average minus the bus average equals the difference average. On average, they're four minutes apart. For sigma of D, I take the standard deviation of both pieces, I square them, and I add them. So the square root of 17, 4.12. That's my new sigma. All right, now, is it the probability that D is greater than 0 or the probability that D is less than 0? Now that one we need to go back and check with the order we did our subtraction, which again, that's one of the reasons why I want you to write this, even if it's multiple choice. On top of that, what happens to the time if you go faster? Okay, that would actually, time goes down. The time it takes you to walk or drive somewhere goes down if you go faster. So on this one, what's the probability that the bus will be faster than walking? That means that the bus time will be less than the walking. So we want the difference to be positive. So probability that D is greater than 0 is going to be normal CDF. And maybe you wouldn't have to write all this out, but I'm going to. And lower is going to be 0. Upper is going to be like 1,000. Mu and sigma is 4 and 4.12. .8342, which is by far closest to A. By the way, it was at, if you get the hundredths partner, you probably just did the D the wrong direction. And on this one, they didn't give us somewhere less than 50%, so I wasn't able to cancel any of those out. But whatever that would be. So if you had positive 0.1658 and you went up here and said, look, none of those are even close, but one of these might be a hundredths partner with my answer, that might be what you need. But anyway, there it is. That's a tough one. That is definitely a tough one. You can see the amount of work shown to get to it correctly. All right, the next one says on a small class of 10 students, 5 are male and 5 are female, and I'm going to draw numbers until I get my first male, which that's not binomial, okay? And then the chances of drawing a male out of the group would be 0.1, not 0.5, so this one's out. And then very suspiciously, though, we have none of the above, which is the correct answer, right? In order for selections to be independent, big N it needs to be 1/10 of the population needs to be bigger than the sample size, or the sample size cannot be bigger than 1/10 the population. Now on this one, we have only 10 students. If I get it on my male on the first one, then it's 1 out of 10, that's 1/10. But if I have to draw 2 or more, which is going to happen plenty of the times, then those are not independent. Not independent, not geometric. All right, 10 and 11. 10 and 11 use this question. I'm sorry, not this question. So we have binomial, mean of a binomial, standard deviation of a binomial, right there. So this one is just n times p. 800 times 0.05. You should have been able to figure out that one 3 years ago. That one is pretty straightforward. The standard deviation, however, is not. That's the square root of 0.05 times 0.95 times 800. So the number times the success times fail. And again, which one is success and which one's fail is not that big of a deal. Because they're looking for improperly attached bottle cap, so maybe that's not really that great. And then we take the square root of that answer, 6.16. Just so easy, right? This stuff is just so easy. Not really, of course. All right, we're gonna roll an 8-sided die 10 times. So 10 times is a fixed number of trials. This one's out and this one's out because these both had 8 trials. So these 2 are out. Just by knowing that it's 10 times. And that means it's binomial. And this is the picking out of the lineup. So 10 choose 3 is my first part. But if I knew nothing else besides that, which shouldn't be much, I still have a 1 in 3 chance of guessing correctly instead of a 1 in 5 guess. And all you that like to pick C when you don't know, you're all luck on this one. The probability of getting exactly 3 sevens. So a 7 is 1 out of 8 rolls, and I need 3 of those. And then 7 out of 8 would be non-sevens, and I need 7 of those. And then my 10 and CR3. And then this one's out because of the 5. And this is the correct answer. And this one's got the exponents in the wrong spot. So anyway, there you go. There's a multiple choice. Under 13 minutes.